let's talk about instantaneous velocity. In velocity, direction matters. In speed, it doesn't. The difference between average and instantaneous velocity is that average velocity is something that happens over an interval of time, whereas instantaneous velocity is something we think happens like that immediately. So for an example of this, I used to travel to visit my wife's family in Sherman, Texas from Cullowhee. Google says you can do this in 14 hours, 11 minutes. There's no way. The fastest we ever did it in 16 hours because we had to stop for things. The distance is 942 miles. Sorry, the distance is 942.5 miles, and I'm going to record that information because we might need it in a moment. What is the average velocity on the part of the trip where I traveled from Cullowhee to Sherman? Well, actually, before I do that, I need to think about what am I going to call which direction. So I'm going to say that from Cullowhee to Sherman was the positive direction. I'm going to put Cullowhee at 0. With this, that means that my position displacement is increasing. So I moved positive 942.5 miles in 16 hours, or about 58.906 miles per hour. Now, what did I go 58.906 miles per hour the whole time? Obviously not. My average velocity was 58.906 miles per hour. But that doesn't mean my instantaneous velocity was always 958.906 miles per hour. So let's think about the difference. Average velocity was this number, 58.906. Was that always the instantaneous velocity? The answer is definitely not. What were some times when the instantaneous velocity in this instance would be the same as the speedometer reading? The reason for that is I'm moving in the positive direction. Like if I was in a neighborhood or stopped for gas or something, I'm going to be going a lot less than 58.906 miles per hour. On the other hand, there were times where I was going faster than 58.906 miles per hour. When I was on the interstate in Tennessee, the speed limit is 70. There are places in Texas where the speed limit is 75. So on highways, I was able to go a lot faster than the average velocity. So we have this idea of instantaneous velocity. If P of X represents the position of an object that is moving in one dimension, then we use P prime of A to represent the instantaneous velocity of the object at time A. When you're dealing with these problems about motion, be sure to distinguish very carefully whether you are looking at P of A, which is the position at time A, or P prime of A, which is the instantaneous velocity at time A. You have to be very careful and look at those and make sure you're dealing with what you want to be dealing with. So let's look at the example of my trip. If I stopped for gas in Knoxville after 2.1 hours, what was P of 2.1? So P of 2.1 represents the position, how far I was from where I started and in which direction. So P of 2.1 would be 121.7, since Knoxville is 121.7 miles from Cullowhee. What was P prime of 2.1? Well, P prime of 2.1, and notice you have to be really careful because sometimes this prime is really not very visible. Look for this prime. P prime of 2.1, if I was stopped, would be 0. I was moving at that instant at 0 miles per hour.